Welcome to Tell Me More Stories Told as podcast.
Great to be here.
Today we're diving deep, really deep, into a hidden world that's literally right under our feet, flowing beneath our cities. Sewage.
That's right. And, it's easy to just think, ooh, gross, and flush it from our minds, so to speak.
Good one.
But we're going on a bit of an adventure today into this huge, unseen network. It's this liquid landscape, really, that shapes our communities, our environment, in ways most people probably never consider.
Exactly. We've done our homework, looked at the sources, traced the flows, and we're ready to unravel the story of what sewage actually is.
And the journey it takes. It's pretty incredible.
Plus, trust us, some of the things found in it are just, well, unbelievable. You're in for some who knew moments, maybe even a wait. Really?
Definitely.
So let's wade in. What exactly is this stuff we call sewage?
Okay, so at its core, sewage is basically the used water that a community produces. Simple as that.
Used water.
You might hear other names for it too, like domestic sewage, domestic wastewater, municipal wastewater. It all points to the same thing.
And it travels through pipes.
Yep, through a whole network of pipes called the sewer system. The whole setup, the pipes, the pumps, everything.
Yeah.
That infrastructure is called sewerage.
Gotcha. So it's not just what goes down the toilet then?
Oh, definitely not. That's just one part. Sewage is really an umbrella term for all the used water from homes, businesses, schools, you name it.
Okay.
Think of it maybe in two mainstreams. First, you've got what we call greywater.
Greywater.
Yeah, that's the water from your sinks, washing hands, dishes also from showers, bathtubs, washing machines.
Okay.
And the key thing here is it's generally considered, let's say, safer. Fewer nasty bugs, fewer pathogens.
Right.
Which means it actually has potential for reuse sometimes. Like you could use treated gray water for flushing toilets or watering the garden, that sort of thing.
That's pretty smart. Reduces water use.
Okay.
So that's greywater.
Yeah.
Then there's the other stuff.
Exactly. The stuff most people picture first.
Yeah.
Blackwater.
Right.
That's the wastewater directly from toilets. So it's got, feces, urine, the flush water itself, and in most places, toilet paper.
Okay.
Yeah.
And that's the one with the higher risk of germs.
Precisely. That's where you're much more likely to find those pathogens, the microorganisms that can make people sick.
Right. Not dinner table conversation, maybe.
Yeah.
But sewage is even more than just gray water and black water, isn't it? I mean, think about everything else that goes down drains.
You're absolutely right. It's a real mix. You've got soaps, detergents washing off us and our clothes. If you have a garbage disposal unit in your sink, a surprising amount of food waste can end up ground up and sent down the drain, too.
Wow. Okay.
And like you said, toilet paper is a big component where people don't primarily use bidets.
So it's this complex soup of, well, pretty much everything water touches in our daily lives.
That's a good way to put it. A soup. And it contains all sorts of things dissolved in it, floating in it. We talk about macro-pollutants, the bigger stuff, but also micro-pollutants, tiny things we'll definitely get into later. Sometimes even bits of solid waste that really shouldn't be there, or even runoff from industrial sites.
Okay, so it's this community-wide cocktail.
Yeah.
Now, people often use sewage and wastewater almost interchangeably. Is there actually a difference? Or does it not really matter?
That's a really good question. And technically, yes, there's a distinction. Wastewater is the bigger, broader term. It includes all used water from homes, industry, agriculture, stormwater runoff, everything.
Okay.
Sewage is a specific type of wastewater. It's the municipal stuff, the water from our communities, the gray water and black water we just talked about.
Got it. So sewage is our town's contribution to the bigger wastewater picture.
Exactly. And one more quick distinction. Sometimes you'll hear raw sewage, which is the untreated stuff straight from the pipes,
Right.
versus treated sewage or effluent, which is the water after it's gone through a treatment plant.
Okay, clear. So this complex liquid mix.
Yeah.
What's it actually like? The look, the feel, beyond just yuck.
Well, you can tell a few things from its characteristics. Temperature, for instance. It's usually a bit warmer than the clean water coming into our houses.
Warmer. Why is that?
Partly from the warm water we use, like showers, but also because it's flowing underground, insulated by the earth, so its temperature is more stable, less affected by weather.
Interesting. Warmer and steadier.
Yeah.
What about color? Was it just brown?
Not always. Freak sewage, like right after it enters the system, is often sort of grayish.
Okay.
But as it travels and sits in the pipes longer, it starts to decompose anaerobically without oxygen and becomes what we call septic. That's when it turns darker, dark gray, or even black.
Right. That sounds more like the image people have And the smell, because we have to talk about the smell.
We probably should. It's not pleasant. Fresh sewage is sometimes described as having a kind of oily, musty, generally unpleasant odor.
Uh-huh.
But that older septic sewage, that develops a really foul smell. That's mainly due to hydrogen sulfide gas being produced.
Ugh, rotten eggs. Got it. And is it clear or cloudy? I assume cloudy.
Definitely cloudy. Very cloudy, actually. We call that hydrobidity. It's full of suspended solids, tiny particles floating around so you can't see through it at all.
Okay, warmish, gray to black, stinky, cloudy, lovely. What about chemistry, like acid or alkaline?
Generally, it hangs out near neutral. The pH is usually somewhere in the range of 6.7 to 8.0, so not extremely acidic or basic.
Good to know. All right, let's dive into that 0.1%. What is actually in sewage besides water?
Right, that tiny fraction holds everything else. It's basically solids, both dissolved right into the water and suspended as particles. And these solids are a mix of organic stuff, things derived from living organisms.
Okay.
Inorganic matter like minerals, salts, grit, and a whole teeming world of microorganisms, bacteria, viruses, fungi.
Wow, a microscopic zoo down there. Let's start with the organic matter. What kind of stuff is that?
Okay, organic matter makes up maybe about half of those solids. It can be particulate, like tiny floating bits, or dissolved, like sugar in coffee. Some of it breaks down easily biodegradable. Some is more stubborn, more inert.
And what's it made of?
It's quite a mix. Roughly, you're looking at maybe 40% protein compounds, somewhere between 25 and 50% carbohydrates, about 10% fats, oils, and grease, FOG, as it's known in the industry, plus smaller amounts of things like urea from urine, surfactants from soaps and detergents, maybe phenols, traces of pesticides.
So a real biochemical soup. How do engineers even measure how much of that organic gunk is in there? Must be tricky.
It is. You can't easily measure every single compound, so we use indirect methods. The main ones look at how much oxygen is needed to break down that organic material.
Oxygen.
Yeah. Biochemical oxygen demand, or BOD, measures the oxygen microbes would use to consume the organic matter over a set time, usually 5 days. Chemical oxygen demand, or SUOD, uses chemicals to measure pretty much all the oxygen-demanding stuff, organic and some inorganic.
Okay, so BOD and acidity tell you how much food is there for microbes, basically, by seeing how much oxygen they'd need.
Exactly. And high levels are a big problem. If untreated sewage with high BOD gets into a river or lake, the microbes start feasting, using up all the dissolved oxygen in the water.
And that's bad for fish.
Very bad. It can suffocate fish and other aquatic life, creating what are called dead zones.
Right. Okay, so managing organic matter is crucial. What about nutrients? I hear about those causing problems too.
Absolutely. Nitrogen and phosphorus are the two big ones in sewage. They're essential nutrients for life, but too much of a good thing.
Well, it causes problems.
Like what?
If sewage with lots of nitrogen and phosphorus gets into lakes or reservoirs, it can cause eutrophication.
What now?
Eutrophication. Think of it as over-fertilizing the water. It triggers huge blooms of algae and aquatic plants.
Those green, scummy layers you sometimes see.
Exactly. And when all that algae dies and decomposes, that process also consumes vast amounts of oxygen, again leading to those dead zones.
So nutrients also lead to oxygen depletion, just indirectly. Where do they come from in sewage? Nitrogen mainly comes from urea in our urine, which quickly breaks down into ammonia, and also from protein breakdown. Phosphorus comes from detergents, though, less now than historically, and also from human waste and food residues. It's usually in the form of phosphates.
Okay, organic stuff, nutrients, and then the really worrying part, the pathogens.
Yes, the disease-causing microorganisms. These primarily come from fecal matter, and they're a major public health concern if sewage isn't handled properly.
What kind of things are we talking about?
It's quite a rogues gallery. Bacteria like Salmonella, Shigella, Campylobacter, Vibrio cholerae, the one that causes cholera.
Wow.
Viruses too, hepatitis A, rotavirus, enteroviruses. Even coronaviruses have been detected in sewage, which became a big topic recently for tracking outbreaks.
Right, I remember hearing about that.
Then you have protozoa single-celled organisms like Giardia, Cryptosporidium, Entamoeba histolytica. These can form tough cysts that are hard to kill.
Yikes. Anything else?
And helminths, parasitic worms, and their eggs. Things like roundworm, hookworm, whipworm eggs can be present, especially in areas with poor sanitation.
That is quite a list. How do scientists even check for all of those? Seems impossible.
It would be impractical to test for every single one routinely, so they use indicator organisms.
Indicator organisms.
Yeah, usually fecal coliform bacteria, especially E. coli. These bacteria live in huge numbers in the guts of humans and other warm-blooded animals. They're not always harmful themselves, but their presence in water indicates fecal contamination.
So if you find lots of E. coli, it's a warning sign that the more dangerous pathogens might also be there.
Exactly. It's like seeing smoke. It strongly suggests there's a fire, even if you can't see the flames directly. It's a measure of risk.
Makes sense.
Mm.
Okay, beyond the biological components, natural or otherwise,
Yeah.
what about the things people flush? The solid waste.
Oh, the stories the sewers could tell. It happens for all sorts of reasons. Sometimes it's kids experimenting, fascinated by the toilet swirl, flushing toys, maybe even socks.
Been there, done that.
What?
With my kids, I mean.
But adults are culprits, too. Obviously, toilet paper is designed to be flushed, but people flush things that absolutely are not wet wipes are a huge problem.
Yeah, I hear they cause fatbergs.
They're a major contributor. They don't break down. They mix with grease. It's bad. Also, diapers, sanitary napkins, tampons, condoms, even expired medications get flushed. All can cause blockages.
Why do people flush medication?
Sometimes just convenience or maybe misguided ideas about disposal, but it's really not good for the environment or the treatment process.
And you mentioned embarrassing items.
Yeah, the privacy of the bathroom sometimes leads people to flush things they want to hide, maybe drug paraphernalia, pregnancy tests, things like that, or just things dropped accidentally, toothbrushes, small toys again.
Wow. Anything else bizarre?
Well, in institutional settings like prisons, clothing sometimes gets flushed deliberately to cause problems. And don't forget, in areas with older combined sewers.
Right, the ones that mix sewage and rainwater.
Yeah. Storms wash all sorts of trash and debris off the streets right into the sewers.
Right.
Leaves, litter, grit, you name it.
It really is a repository for everything. Now, you mentioned a fun fact earlier about people sorting this stuff.
Well, fun might depend on your definition, but yes, at the very start of a wastewater treatment plant, there are usually coarse screens or grinders, and someone's job involves removing the really big stuff that gets caught there, rags, wood, plastics, all those flushed items we talked about.
So they literally see everything.
Pretty much. They find some strange things, apparently. Wallets, phones. It's a tough but essential job to protect the downstream equipment.
Hats off to them. Okay, so that's the bigger stuff. What about those micro-pollutants you hinted at, the invisible contaminants?
Right, these are chemicals present in really tiny amounts, parts per billion or even trillion, but they can still be a concern. Think pharmaceuticals, traces of medicines we take that pass through our bodies.
And so our prescriptions end up in the sewer.
A portion often does, yes. Also, things like trihalomethanes, which can be byproducts of water disinfection further upstream. And a big one nowadays, microplastics.
From what?
Tiny plastic beads from some cosmetics or cleaning products, but mostly tiny fibers shedding off synthetic clothes, polyester or nylon when we wash them. Also, bits from degrading plastic packaging.
Wow, our clothes are polluting the sewers.
In a microscopic way, yes. Also in this category are endocrine-disrupting compounds, chemicals that can interfere with hormones and hormones themselves that we excrete.
This is getting complicated. Anything else microscopic?
Well, there's also improper disposal. People pouring used cooking oil down the sink, big no-no, causes blockages. Also leftover paint, solvents, harsh detergents, disinfectants.
Oh, is that bad? Doesn't it just get diluted?
It gets diluted, but these chemicals can be toxic to the beneficial microorganisms that treatment plants rely on to break down the waste. They can disrupt the whole process.
It really shows how our household habits impact this huge system, doesn't it? Okay, so we have this complex mix. How does it get from point A, our drains, to point B, wherever it's going?
It starts with collection. In most developed areas, it flows through underground pipes, mostly using gravity, just slipping downhill.
However.
And there are two main types of systems. Sanitary sewers are designed to carry only sewage wastewater from homes and businesses. Stormwater runoff is handled in separate pipes.
Okay. And the other type?
Combined sewers. These are often older systems, especially in city centers. They carry both sewage and stormwater runoff in the same pipe.
So when it rains?
Exactly. When it rains, all that rainwater flowing off streets, roofs, and parking lots goes into the same pipe as the sewage.
Doesn't that dilute the sewage?
It does,
Yeah,
significantly. But it also massively increases the volume of water flowing through the pipes. And that runoff isn't clean either. It picks up oil, grit, metals, bacteria from pet waste, litter, all sorts of urban pollutants.
So combined systems have their own challenges. Does sewage get diluted inside the pipes too, even without rain?
Yes, a couple of ways. One is infiltration. Older sewer pipes, especially, can have cracks or leaky joints. Groundwater can seep into the pipes.
Ah.
This increases the total flow, diluting the sewage concentration, but it might also bring in contaminants from the groundwater, depending on what's in the soil.
So leaky pipes dilute things, but maybe add other issues. What else?
Well, besides stormwater in those combined systems, you can also have industrial wastewater discharges. Many industries send their wastewater into the municipal sewer system, sometimes after pre-treatment at their site.
So factories add their water too.
Yep. This adds volume, which dilutes the concentration of household sewage, but it also adds whatever specific pollutants are in that industrial discharge, even if they are also diluted by the household sewage. It's a constant mixing process.
The dynamic flow down there. So once it's collected, mixed, diluted, where does it actually go? What's the end of the line?
There are several possibilities for final disposal or discharge. Historically, the simplest was just dilution, letting it flow into rivers, lakes, or the ocean.
Dumping it.
Pretty much, yeah. Or using marine outfalls, long pipes that carry sewage, sometimes with minimal treatment, far out into the sea, relying on the vastness of the ocean to dilute and break it down.
Okay. Other options?
Land disposal is another route. This could be sewage farms, which we can talk more about, or evaporation ponds in dry climates, or infiltration basins where the water soaks back into the ground. Sometimes highly treated water is even used to recharge groundwater aquifers.
That dilution idea, just letting it flow into rivers, doesn't that just pollute the river? Seems obvious.
You're right, it absolutely can. Natural water bodies do have some capacity to purify themselves. It's called assimilative capacity. Microbes in the river can break down some waste, but that capacity is limited. It depends on how clean the river is to start with, how much water is flowing, and crucially, how much pollution you're adding. Overwhelm that capacity, and you get serious pollution.
So there must be rules now. You can't just dump raw sewage anywhere.
Oh, absolutely. In most parts of the world, there are strict regulations. Wastewater has to be treated to meet specific quality standards before it can be discharged into the environment. These standards vary depending on where it's going. A small stream needs much cleaner water than the open ocean, for instance.
Right. And those marine outfalls you mentioned, discharging into the sea.
Yeah.
Is that still common?
Yes, very common globally. Thousands of them exist. The idea is that the ocean offers immense dilution, and factors like saltwater and sunlight help naturally disinfect and break down the waste over time. Often the sewage going into these outfalls only gets primary treatment, basically just removing the big solids.
Still feels a bit like sweeping it under the rug, or under the waves maybe. Yeah. What's the global picture like? Does most sewage get treated now?
It's a mixed bag. Historically, direct discharge was the norm everywhere. Industrialized countries have largely moved towards widespread wastewater treatment, though upgrades are always needed.
But not everywhere.
No. In many developing countries, infrastructure hasn't kept pace with population growth and urbanization. A huge percentage of wastewater, both municipal sewage and industrial effluent, is still released into rivers and coastal waters with little or no treatment. Some estimates suggest maybe 80% of global wastewater is discharged untreated.
80%, wow. That's a massive environmental challenge.
It really is. It impacts water quality, ecosystems, and human health through waterborne diseases. Treatment levels vary hugely based on a country's income and resources.
So treatment is clearly the way to go. What does that actually involve? What happens at a treatment plant?
It's usually a multi-stage process designed to remove different types of pollutants. First up are typically bar screens. Think of them like big metal rakes.
To catch the big stuff, the toys in white.
Exactly. They remove large debris that could clog up pipes or damage equipment later on. Grit removal often follows, settling out sand and gravel.
Okay, screening out the junk. Then what?
Then comes primary treatment, or primary sedimentation. The sewage flows slowly through large tanks, allowing gravity to do its work. Heavier solids settle to the bottom as sludge.
Sludge, right.
And lighter materials like grease and oil float to the top as scum. Both are skimmed off. This stage alone can remove about half the suspended solids and maybe a third of the BOD.
So a good first cleaning step, but it leaves dissolved stuff behind.
Yes. Lots of dissolved organic matter and finer particles remain. That's tackled in secondary treatment. This is usually a biological process.
Using those microbes you mentioned.
Exactly. They create conditions where helpful microorganisms thrive and essentially eat the dissolved and fine organic pollutants, converting them into carbon dioxide, water, and more microbes, which then form clumps that can be settled out.
Like an activated sludge system.
That's a very common method, yes. Or trickling filters, where sewage trickles over media covered in biofilms. The goal is to significantly reduce the BOD, though it works less well if the sewage is already very dilute, like during heavy rain in combined systems.
Okay, so primary removes solids, secondary removes dissolved organics. Is that it?
Often there's a final step, disinfection. This is crucial to kill or inactivate any remaining harmful pathogens before the water is released.
How do they disinfect it?
Common methods are chlorination, adding chlorine, or using ultraviolet UV light, which damages the DNA of microorganisms so they can't reproduce. Disinfection is much more effective after the solids and organics have been removed in the earlier stages.
Right, less stuff for the pathogens to hide in. Okay, so treatment cleans it up, but then it just gets discharged. Seems like a waste of water, in a way.
That's an increasingly important point. Why just discharge it when it could be a resource? Wastewater reuse and reclamation is a growing field.
Reuse? How?
Instead of discharging the treated effluent, it can be used for beneficial purposes. Irrigating farms or golf courses, watering parks, industrial processes like cooling, even sometimes for flushing toilets in large buildings.
So giving the water a second life.
Exactly. Of course, it has to meet very strict quality standards, depending on the use, to protect public health and the environment. But it's a much more sustainable approach, especially in water-scarce areas.
And can you recover other things besides water? You mentioned nutrients earlier.
Yes. Resource recovery is a really exciting area. Sewage contains valuable nitrogen and phosphorus fertilizers, essentially. It also contains carbon, which has energy potential.
Energy?
Yeah. The sludge produced during treatment can be digested anaerobically to produce biogas, mostly methane, which can be burned to generate heat or electricity, often powering the treatment plant itself. There's active research into improving ways to recover nutrients and energy efficiently.
Wow, turning waste into energy and fertilizer. That's thinking differently. What about those sewage farms you mentioned? Are they still a thing?
They are, though maybe less common now in highly developed countries. A sewage farm is basically land where raw or minimally treated sewage is applied for irrigation and fertilization.
It's just spread on fields.
Essentially, yes. It's often practiced in warm, arid climates where water is scarce and the nutrients are beneficial for crops. The solids break down and enrich the soil.
Sounds a bit risky, health-wise.
It can be, if not managed properly. There are risks of pathogen transmission to farm workers or through crops, plus odor issues. That's why it's less common where stricter regulations and more advanced treatment are in place. But it's a low-cost method used in some regions. It's quite different from modern, controlled agricultural reuse of highly treated effluent.
Got it. So all of this collection, treatment, reuse, disposal must all be tightly controlled by laws, right?
Absolutely. Sewage management is heavily regulated. There are rules for how it's collected, transported, how thoroughly it must be treated, and what quality standards the final effluent must meet before discharge or reuse.
And dumping untreated sewage is illegal.
Generally, yes. Uncontrolled discharges are prohibited in most places. These regulations are usually part of broader sanitation and environmental protection laws aimed at safeguarding public health and water resources.
It's this huge, vital, complex system operating mostly out of sight, out of mind.
It really is. It's a massive feat of engineering and ongoing management that allows our towns and cities to function safely. We kind of take it for granted.
Before we wrap up this rather fascinating journey, just a quick reminder, if you're finding these hidden stories intriguing, do hit that subscribe button. You won't want to miss future deep dives here on Tell Me More.
Yeah, it's amazing how this topic connects to so many things. Public health, engineering, chemistry, biology, environmental science, even resource management now.
Definitely. So the next time you flush the toilet or watch water go down the drain, maybe pause for a second. Remember this incredible, complex journey happening beneath your feet.
It's quite a testament to community infrastructure and the ongoing effort to manage this essential but usually invisible flow.
What really stood out to you during this deep dive? Any big surprises?
For me, I think it's the sheer range of things that end up in sewage, especially the micropollutants, the medicines, the plastics. It really drives home how interconnected everything is. Our daily actions have ripple effects.
Yeah, I agree. It's like a liquid reflection of our society, warts and all.
So here's a thought to leave you with. Looking ahead, imagine a future where we don't just see sewage as waste to be treated and disposed of, but as a rich stream of resources, water, nutrients, energy.
Right, like urban mining.
Exactly. What innovations in technology or maybe even policy could help us truly harness that potential on a large scale? Could we flip the script entirely and start calling it resource water instead of wastewater?
That's a really powerful thought. Moving from disposal to recovery, lots to think about there. Thank you for joining us on this exploration into the depths.
My pleasure.
Until our next story on Tell Me More Stories Told Us podcast, keep those curious minds flowing.